Welcome students, hi. So now we are in chapter 3 of the SP. We are now going to study the properties of linear time invariant systems or LTI systems. At the end of this chapter, you should be able to understand the relationship between input signal, system and output signal, convolution, classify systems, and understand the properties of LTI systems. So previously we have studied the continuous time signal and the discrete time signal. So just a revision, yeah. So continuous time signal, it's is denoted by xt, and then the xn is the discrete time signal atau digital time signal, and the time, okay, time is t, and digital signal or discrete time signal is denoted by n. Okay, so for a discrete time signal, it is periodic if xn equals to xn plus capital N, and it is within from negative infinity to infinity. Capital N is arbitrary interval selemasa and periodic in time. So other conditions from other than this will make the signal non-periodic. So if you're given a signal that is xn equals to 2 for n n at 2, 4, and 7, and then negative 1 for n at 1 and 3 and 0 elsewhere. So you can draw the signal as impulse signal. So now 2 amplitude 2 xn equals to 2 pada 2 and 4 and 7, okay, and negative 1 pada 1 and 3, and so the rest is 0. Okay, for non-periodic signal, okay, types of non-periodic signal, this also we have seen it in the previous section ataupun chapter. So delta function ataupun impulse function which exists only at n equals to 0. Other than that, the function is non-existent. So delta n1 is for n n0, and 0 for n not equal to 0. Okay, so dia ada satu sahaja signal di n0. Types of non-periodic signal lagi, unit step function, sorry. It exists only when n is smaller or equal to 0. Okay. Oh, sorry. Ini ada salah kat sini, n equals to bigger or equal to 0. Okay, so the step function dia di sini adalah 1, so nilai dia adalah 1 for n bigger or equals to 0 and 0 for n smaller than 0. Okay, rectangular function similar to step function, cuma dia ada had dia. Okay, so it's if you it's between n0 to n1. Okay, so ada dia dalam bentuk rectangular. Okay, so n1 for n bigger than n0 and smaller for n1. So you determine lah kat mana lokasi dia. Okay, can be anywhere as long as it's the shape of a rectangle. Okay, so ramp function. A ramp function exists only when n is bigger than 0, and so xn equals to n for n bigger or equals to 0. So pada n0 dia jadi 0, n1 dia xn pun 1, n2 xn pun 2, n3 xn pun 3, and so on. Okay, right. When we have written the discrete time signal into impulses, okay, so we can write them as summation. Kita dah tengok hari tu. So if you look here, you have the xn equals to negative, dia start dari sini, negative x negative 3, okay, to show that this is xn, okay, delta n plus 3 plus delta x negative 2, delta n plus 2, because dah kasih dia tu okay, and so on. And this is the compact form of the this persamaan. Alright. This is called the shifting property. Okay, bukan shifting, shifting property. Since the sequence is a linear combination of shifted unit pulse delta n minus k, where the weights in the linear combination are xk. So dekat sini maksud dia, okay, why is it shifting? Shifting ni kita ambil daripada word sift. Okay, bila kita sift, okay, kita nak buat cake kan. So kita sift the flour, and then apa yang sangkut dekat kita punya penapis tu is the unwanted lah. Okay, but sift means that you take out what is important sahaja. Okay, so that is why it is called a shifting property, because of the weights ni, coefficient of the weights yang ada pada impulse. That is what it is referring to. So it's not shifting property, it is shifting property. So a system pula, okay, a system is any system that operates with an input signal and yield an output signal. So apa-apa signal masuk ke dalam sesuatu itu, dan benda tu memproses signal tu ataupun mengubah signal tu, it is called, that particular thing is called a system. Alright, and it is and dia akan keluarkan output. So you have Xn as your input signal, then you have Hn as your system, and then Yn is your output signal. Alright, so dalam kes contoh kalau kita ambil low pass filter so you have a sample, this is your punya signal, okay, so kita ada you punya system, okay, so you masukkan signal ni ke dalam system you, so this is your output. Okay, high pass filter, so you have this signal, then you have your system yang masukkan, and then you have your high frequency punya signal keluar dekat sini kan, sebab dia punya this is a high pass filter. Okay, so basically ini contoh sistem. Okay, so the process yang nak proses antara signal input dengan sistem dipanggilkan sebagai convolution. So Xn and Hn are two different sequences, so they are actually sequences, both of them are sequences. Yang ni kita tahulah as dia is a sequence of numbers. Hn is also a sequence of numbers. So this sequence is Yn is generated through convolution sum. Okay, so it can be written as such: Yn equals to summation of xk times Hn minus k. Okay, atau Yn equals to the summation of Hk times Xn minus k. Alright, so dekat sini both are convolution. So sometimes, okay, k ni digantikan dengan lambda. Okay, so what bak kata pepatah Melayu apa ni, sekilas air di ikan di sungai tahu jantan betina, gitulah. So you understand the shape of the persamaan, so whatever yang dia tukar kat dalam ni n dengan k ni tak kisah, okay, but as long as it is in this form, it is called convolution. Okay, so what is the process involved in convolution? So basically there are 4 operations dalam convolution. So you have dekat sini folding. Okay, so kita tengok Yn equals to k from negative infinity to infinity. So k is your sample number. Okay, k is your sample number. Alright, and n, okay, is your delay. Alright, so this is sample number, n is your delay dalam case ni. So there are 4 operations. So folding, okay, so xk ni, negative k is folding, and then ada delay sebab ada n, and then you have multiplication, so xk darab dengan hn minus k, And then ada summation. So means that all this, because of K, sample number tu, then you have to tambahkan semua sample number tu. Okay. So, now important ya. So, you kena differentiate. Dulu, sebelum ni kita sebut N tu sample number kan. Okay, for convolution, kita sebut K tu sebagai dia punya sample number atau sequence. And N is the delay. Alright. Now, apa yang kita kena buat? Okay. Alright. This is the standard notation. Okay. Tadi dia punya mathematical notation. Ini adalah standard notation. Kalau tulis macam ni means dia ada convolution. Alright. So what we have to do is we rewrite dulu xn jadi xk. So that's why k tu jadi sequence number sebab kita menulis semula. Alright. And then we fold. Okay. In this case kita sebab hn dekat sebelah kanan. Okay. So hn sebelah kanan kita kena buat operasi pada hn ni. Xk ni duduk diam dulu. Alright. So fold hk to obtain h minus k. Right? So then multiply xn with hn minus k. Then you sum the result. Then kita delay hn minus k by one sample to the right and repeat step 3 and 4. Then kita repeat semua kita repeat the delay ni 5 ni. Okay, sampailah kita habis sequence. Okay. So kita tengok ya macam mana proses dia. Okay, so find yn when input signal is xn and the impulse response is hn. So kita ada xn dan kita ada hn. So here you see that kalau kita tulis dalam jujukan masa, jujukan nombor, xn is 0, 1, 2, 1. Okay, so 0, 1, 2, 1. Hn pula adalah dia pada n kosong dia adalah 2 sebab tu ada arrow dekat sini ya. So ini adalah 2 2. Okay, so ini adalah 1 1. So you have 1 1 2 2. So arrow dekat bawah n equals to 0. Okay. So saya ni tuliskan. So remember this is yang arrow ni is n equals to 0 Okay, kemudian first tadi kita kena rewrite So we have to rewrite xn and hn kepada xk ke nhk. So we change xn to xk, hn to hk. Kita tukar saja dia punya label ni. Alright. So n jadi k, okay. N jadi K, and then dia pun sama juga N jadi K. Right? So you rewrite that. And then, okay, we fold the HK. Alright? So kita nak dapatkan H minus K. So we fold. What is folding? Folding is kita sort of lipat the signal. So apa yang ada berada di kanan jadi ke kiri. Okay. Apa yang berada di kiri jadi kanan. So, you fold at n equals to 0. Fold dekat sini. So, all of this goes to all on the right go to the left. All on the left goes to the right. Okay, so you have H minus K. Now, once you have completed that, okay, so you multiply each sequence. So, ni kena multiply. Okay, apa ni? 2 kena multiply dengan kosong. Okay, sorry, you kena align dulu ya sequence ni. Xk dengan H minus K, alignkan kosong dengan kosong. So, this is kosong. Okay, so this is kosong, dia align kat sini. Ni adalah negative 1, align. So, you have to multiply each of the sequence. Okay, cara yang mudah adalah you tuliskan dalam bentuk table, okay, ataupun kaedah ni dinamakan sebagai sliding ruler. Okay, so you tuliskan dalam bentuk table. So K is sample number, okay, and then XK apa value dia, H minus K apa value dia. Okay, so you tuliskan dalam bentuk table, senang sikit, then you buat you punya the operasi of multiply. So dekat sebelah sini XK signal yang pertama tadi, this is H minus K, and then so N kosong, tak ada delay apa-apa ya, no delay at all. So dia sama macam H minus K. So H0 minus K is sama dengan H minus K. Okay. So dekat sini sama. That's why this one sama dengan this one. Right. So tapi kita kena tulis juga walaupun dia sama. So at this point, okay, you darabkan. This you darab dengan ini, value ni. This one darabkan dengan value di sini. This one darabkan dengan value di sini. This one dengan value di sini. This one dengan value di sini. Okay. So you darab, then you have nilai dia 0, 0, 1, 2, 0, 0. Kosong lah, semua yang lain kosong. So after you dah darab, you kena summation. Okay. So you have to summation, sumkan all these numbers. Okay. So tadi sumkan and you dapat 3. Right. Then the next step is you have to delay by one sample to the right and repeat step tadi. So you kena, so tadi dekat this is the signal ya, no delay tadi. Right, then you kena anjakkan satu sahaja ke kanan. Alright, so this one, okay, anjak ke kanan. Semua anjak ke kanan. Okay, anjakkan ke kanan. Alright, so once you have move it to the right, okay, apa yang you kena buat lagi? You dah delay, and then you multiply, then you tambah. Okay. So bila you anjak tadi, okay, so dah anjak satu kan, so N delay ni sebanyak satu sampel. So tulis satu. So this is H1 minus K. Alright, so dah anjak, tuliskan sedemikian. Alright, tulis dekat sini. Ya, anjak satu. Okay, bila dah ni, tulis dekat this one, you write as, okay, you write as Y1. Okay, Y1. Okay, darab. Okay, so again sama juga macam tadi. So this part, okay, darab dengan atas ni, yang ini darab atas ni, yang ni darab atas ni, yang ni darab atas ni, dan this one darab atas ni. So you get 2, 2, 1. Okay, and then you tambahkan semua, dapat 5. So you ulang ni semua. Okay, ulang the steps, repeat until there is no overlap of sequence. So bila you ulang, anjak ni kan, ulang sampai this is the end of your sequence kan, this is the end of your the first XK, alright, and then this is your last dekat sini, alright, ni dah last, so tak ada lagi dah, tak ada overlap. So bila this part means that dia akan dapat kosong. So berapa delay kat sini? Okay, so this is Y1 is satu kali delay, okay, satu kali delay, Y2 dua kali delay, Y3 and 3, Y4 and 4, okay, and then you have Y5, okay, and 5. Okay, pada ni dah tak ada. Alright, so that is how you do the convolution. But okay, but dia ada but. If we look at the original signal tadi, okay, the two sequence tadi, so you have this is kosong, and then you have this is negative 1. So dekat sini what happens is that you kita tadi kan kita dah fold, okay, when we folded the signal, okay, alright, so when tak fold ya. So when we fold the signal, okay, when we fold the signal, we have this one becomes, this is not x1 man. Okay, so when we fold the signal, okay, you have bila dah fold signal tadi, you tengok dekat sini dia masih ada signal yang tak didarabkan ya, sebab kita start so here is 0 tadi ya. Okay, so let's look at the table. Okay, So bila kita dah folding tadi, okay. So this once you dah, ini kita dah fold and then kita terus move to the left kan. Alright, but as you can see, okay, there are signals yang tak didarabkan dengan apa ni, dengan lengkap, okay, not completed. So actually this all the signals ni must multiply dengan all of xk. H minus k must multiply dengan all of the signals ni. Okay, so dekat sini kalau you nampak this part, okay, satu ni tidak dimultiplikan dengan satu di sebelah sini. So what you have to do is, okay, you kena anjakkan ke, tulis semula, this is the result of folding. So you anjakkan ke kiri, okay, supaya dia align dengan xk. Okay, so bila you anjak ke kiri, n equals to n, nilai dia adalah negatif 1. Alright, nilai dia adalah negatif 1. So dia kat sini adalah h, okay, minus 1 minus k. Alright, so dekat sini, then you buat lagi sekali benda yang sama. So this one multiply dengan this one multiply dengan this one multiply dengan this one multiply dengan sini. And then tambahkan, so you get 0 plus 0 plus 0 plus 1 kan, sebab dah multiply. So y minus 1 equals to 1. Okay, and then bila you anjak sekali lagi, okay, so dah habis dah signal ni, dah tak ada so dah habis maksudnya bila you gerakkan ke kiri tu until the sequence tidak lagi overlap juga. Alright, so pada anjakan n equals to negative 2, okay, you have 0. Okay, so the result of the convolution is di yang ini. Okay, so kita boleh bila you dah susun balik tu, okay, yn you dapat value yang ini. Okay, and then you boleh lukis balik semula. Okay, balik lukis, then you akan dapat nilai ni. Alright, so kita tengok satu lagi example. Okay, satu lagi example. You see that given two signals as input and system impulse response, xn dengan hn. So kalau you tengok dekat sini, dua-dua signal ini bermula dengan kosong. Okay, bermula dengan kosong. So kita tengok apakah dia punya result of the convolution. Okay, so bila kita fold, okay, so ni k ditukarkan jadi lambda so n ditukarkan kepada ni is sample number. Okay, so apa sahaja method yang you nak, cara nak tulis tu no, tak ada masalah as long as you know what you are writing. Okay, so dekat sini as you can see, you ada this two signals. So when you fold means that all of the signals goes to the left. Okay, so all of that signal goes to the left. Alright, so dia align dekat n kosong ni, dekat n kosong. So dekat sini means that dia start daripada awal. Tak ada case yang macam tadi where ada yang tertinggal, because before this the signal was two-sided signal. So yang ini adalah dua-dua adalah right-sided signal ataupun right-sided signal. So bila you fold, dia start dengan kosong. So you terus dia anjakkan dia ke kanan. So you don't have to anjakkan kiri ke kanan lagi. Alright. So from here, the same thing that you must do. So you darab. Okay, darabkan yang atas ni. Then you have darab and then tambah dapat 1. Okay. Then you anjak lagi sekali, you darab dan tambah dapat 3/2. Okay. And you continue sampai habis. Sampai dia dah habis, there is no overlapping of the signal. Alright. When there is no overlapping of the signal, then you can stop the operation. Okay, so that is convolution. Okay. Now, for circular convolution adalah untuk periodic for periodic continuous and discrete time system, the output of yt and yn are defined as such. Yeah. Alright. So basically, when you circular convolution is when the signal is periodic. Okay. So kita guna circular convolution for periodic signals. Okay. Again, given two samples, two signals xn dengan xhn. So kita nak try buat dia punya circular convolution, alright, circular convolution. So here, okay, kita gunakan hn. Kita jadikan dia periodic, okay. So jadikan dia periodic 11100 1100. Okay, so kita tulis dalam table tuliskan 1100, okay, 1100. Dan dekat sebelah sini pun kita repeat the same signal, okay. Bila kita repeat, so this is periodic. And then macam tadi, so the xn, okay, kita dah fold, okay, kita start dengan n kosong, ya, n kosong, fold. And yang ni tak payah ulang-ulang. Yang satu sequence saja yang you ulang-ulang. Tak kisah nak sequence H atau sequence X. Mana-mana boleh. Because if you go back to the definition of convolution, dua-dua tu sama. Yeah? Alright. So then again, the process is the same. You anjakkan dia ke kanan. Okay, anjakkan dia ke kanan. Dan sampai, okay, sampai banyak mana yang you mampu. So what you will get is a similar value, okay, similar values macam yang kita buat linear convolution, cuma dia periodic juga. So you have 1, 3/2, 7/4, 3/4, 1/4, nanti ulang balik 1, lepas tu 3/2, 7/4, 3/4, 1/4 and so on. That is circular convolution. And then untuk correlation, so there is another process called correlation pula. So kita correlation two sequences and the similarity between them between these two sequences are measured using cross correlation. So cross correlation bila kita nak bandingkan dua signal yang berbeza. Autocorrelation adalah bila kita nak bandingkan signal yang sama. So you have dekat sini kalau tengok cross correlation YX, yang ni XX ataupun YY. Okay, so dia punya persamaan ni, okay, lebih kurang sama macam dengan convolution. The only difference is, okay, this one and, okay, and then you have your punya L is dia punya delay. Okay, so L adalah delay. L adalah delay. L is the delay, okay, and N adalah dia punya sample. Okay. Now dekat sini kalau tengok tadi, okay, kalau kita tengok dengan bandingkan dengan convolution, okay, dia punya delay adalah di sebelah depan, okay. So you have here and kalau kita guna notation yang ini, so kita ada this is n, delay minus n, okay. So terbalik dengan yang ini, okay, terbalik. So L minus n kalau yang convolution tadi, so dekat sini, okay, you don't have this problem. So the operation for correlation sama macam convolution, cuma dia tak ada folding. Okay, there is no folding in this particular for correlation. Okay, so dia punya steps are similar, the same actually, but tak ada folding. Itu sahaja. Okay, so for correlation, selalunya digunakan untuk sonar, where they send signals in the ocean, and then dia nak detect dia akan bandingkan signal yang dia hantar tu dengan signal yang dia dapat balik. So similarity antara tu yang akan menentukan what is the signal yang apa yang dia nak cuba detect di bawah laut, ataupun dekat information new students from telecommunication pernah dengar ni nak test signals that is yang dipancarkan ke satellite, okay, and then vice versa. Right, so conclusion, conclusion, okay, in this diagram, you can see that convolution, okay, you have two different sequence, and then you have to you have to buat folding, okay, so you see there's the folding here of G, okay, the folding, and then you must make sure that all of the sequences mesti dioperasikan, di multiply, ataupun you have to be convolved with each other. That's why tadi in the first sequence tadi, because it's a two-sided sequence, so you have to do ke kiri atau ke kanan. Ke kanan dan ke kiri, because you have to make sure all the sequences are convolved. Alright. And then for cross correlation, so you see there is no need for folding. Alright, there's no need for folding, and you must make sure that every signal must be cross correlated. Okay. Right. So I should add also, in the case of when you have the two-sided sequence tadi, right? So you can actually, okay, if you want to be smart about it, okay, if you see that the signal is as such, okay, saya guna yang ni lah, okay. When you see the signal that is two-sided, okay, so you see that it is two-sided, you anjakkan siap-siap permulaan sequence dengan akhir sequence. Okay, so bila you buat begini, okay, so you tak perlu ke kiri ke kanan lagi. Okay, what you need to be alert is that bila you samakan dia punya N ni ataupun K ni you samakan dengan awal dengan akhir, samakan dengan awal sequence dengan akhir sequence, alright, you must make sure how many anjakan yang you buat untuk memastikan dia sama. Okay, so kalau dalam kes ni kita kena anjakkan satu. Okay, so kita kena anjakkan satu, so dekat sini you start dengan negatif 1. Okay, you start dengan negatif 1, so nanti bila you start anjak ke kanan, okay, you anjak ke kanan, so bila anjak ke sini dia akan jadi yang asal balik kan. Bila dia anjak ke sini jadi asal balik, so dia adalah N kosong. Faham tak? Sebab dia dah sama dengan yang atas, maksudnya bila sama dengan atas maksudnya there's no anjakan, so N kosong. So then you buat balik semula dia punya multiplication dengan summation, and then bila you anjak sekali lagi ke sini then dia jadi N1, begitu. Alright, so you have to take note there bila you want to start dengan when you are doing with two-sided sequence. Okay, so you can use any method that is of convenience to you. Alright, so sekarang kita tengok pula okay, so kita tengok ya. Alright, this is slide tambahan, okay, which includes Z transform. So kita ingatkan yang sebelum ni we have seen that xn can be written as jujukan nombor, and it can be written quickly as the Z transform of as such. Okay, so bila kita and for this is sequence 1, sequence 1, and then you have sequence 2, okay, sequence 2, okay, sequence 2. So 1 pada 0 to 5. So this is basically a rectangular punya function. So bila you ada sini, this is if you write this x to n equals to 1 1 1 1 1 1 2 3 4 5. Okay, so this sorry 6 6. So dia ada kosong kosong, 1, 2, 3, 4, 5. Alright, so you boleh tuliskan dia punya Z transform terus 1, Z to the power negative 1, Z to the power negative 2 sampailah Z to the power negative 5. Okay, then, okay, fast way to do convolution is that when you have this two Z transform, you boleh darabkan sahaja X1Z dengan X2Z. Okay, bila you darabkan kedua-dua persamaan ini, so you have this persamaan and this is then you have persamaan yang ini, and then from here you boleh tuliskan dia punya xn, kan, sebab ini satu, okay, satu negatif satu, satu negatif satu, dan ada, okay, so let me write here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you boleh tuliskan dekat sini. So you have here, okay. Okay. So you have here that's a easy way of you buat convolution using Z transform. Okay. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Oh, tersilap ni. Patutnya tak ada satu ni. Okay. So this one so there's no 8 ni. Okay. Right. So bila nak buat nak permudahkan daripada persamaan yang ni kepada persamaan yang ini, okay, so you have to use this lah, rules of exponents. Macam mana kalau x darab dengan so a to the power of x darab a to the power of y, jadi kuasa dia tambah, okay. Dan kalau bahagi, kuasa dia tolak. So you have to use these rules lah to get this result, ya. So tak adalah nanti so so that you can use this easily. This is how you can do convolution also. Okay. If it's not stated which method you should use, then you are free to choose any methods that you want to use. Alright. Okay, so kita stop dekat sini dulu. Okay, dan kita akan sambung dengan properties of convolution and linear time invariant systems. Okay.